Hi friends, today we discuss about radioimmunoassay or RIA. It's a in vitro assay used to detect concentration of specific antigens present in sample. So it's include a radioisotope and antigen antibody interactions. The commonly used antigens are iodine 125, hydrogen 3 and carbon 14. Then H3 means it's a tritium. Then it's a most specific and sensitive method to detect the concentration of antigen, antibody, allergens, hormones or drugs. The RIA method, which is used to detect the allergens present in the blood, is called RAST. RAST means radio allergo sorbet test. It is used to detecting the presence of allergens present in blood. So the basic principles of radioimmunoassay is it's mainly based on the competitive binding between radiolabeled antigens and unlabeled antigens with selected antibodies. So finally we select the supernatant and measuring the radioactivity of the samples. Then there are two types of radioimmunoassay. They are qualitative and quantitative. Then the methodology of radioimmunoassay is, first of all, we are discussing the qualitative radioimmunoassay. In the case of qualitative immunoassay, we first taking a antigens. It's considered as a X, antigen X. It first radio labeled with iodine 125. So it's a radioactive labeled or radioisotope labeled antigen X. The red color is representing radio-labeled antigens. The radio-labeled antigen is first put into the antibody collected or antibody taken in the microtitrate plate. Then second step is the radio-labeled antigens are bind with the antibodies. So the radio-labeled antigens bind with its specific antibodies present in the microtiter plates. So microtiter plate is only contain the complex. The unbounded radiolabeled substances are washed off. Then to this complex we adding the sample. So the sample is containing unlabeled antigens. So they are called cold antigens. So the cold antigens are replaced the radiolabeled antigen at the specific antibodies. So some antigens, that means some radiolabeled antigens are become free in this microtiter plates. So this free radiolabeled antigens are mainly responsible for the radioactivity. So the free radiolabeled antigen is responsible for radioactivity. So the radioactivity is dependent upon the concentration of cold antigen present in the sample. So finally we take the supernatant by centrifuging. So the supernatant is containing radiolabeled antigens. These radiolabeled antigens are responsible for the radioactivity. Then finally we analyze the radioactivity of these samples. This is the qualitative method. In this qualitative method, we using two type of buffers are used for washing out. They are, first one is 1% trifluoroacetic acid. Then second type of buffer is 60% acetonitrile plus 1% trifluoroacetic acid and 39% distilled water. These two buffers are used for washing out. They are mainly used to washing out the different proteins present in the blood samples. So it's the qualitative analysis. Then second type is quantitative method. The quantitative method is almost similar to the qualitative methods, but the major difference is we adding a standard of cold antigens with known concentrations. The first step is exactly similar to the qualitative method. That means we adding radioactive antigens to the antibody, then it's form antigen antibody complexes, then unbounded antigens are washed out. Then to this complex we adding a standard cold antigen with known concentrations. The adding concentrations are representing their 1 nanogram per milliliter cold antigen, 2 nanogram per milliliter cold antigen, 3 nanogram per milliliter cold antigen, 4 nanogram per milliliter cold antigen and 5 nanogram per milliliter cold antigens. So this each concentration representing different radioactivity. So first of all, 1 nanogram per milliliter cold antigens replacing some amount of radiolabeled antigens, such responsible for 10% radioactivity. Then 2 nanogram per ml cold antigen responsible for replacing some concentration of radiolabeled antigens is responsible for 20%. So similarly, the 3 nanogram is responsible for 30% radioactivity, 4 nanogram is responsible for 40%, 5 nanogram is responsible for 50%. Based on this radioactivity, we plotting a standard graph. So based on this standard graph, we measuring the quantity of the sample. That means we have a blood serum, then we adding to the blood serum to the radioactive labeled antigen plus antibody complexes. So it leads to the replacement of, or the antigen present in the samples leads to the replacement of radioactive labeled antigens. So this replaced or free form of hot antigens are responsible for radioactivity. So we measuring the radioactivity, so we got the specific value of radioactivity. So this axis is representing the radioactivity. If we get any measurement of radioactivity, we got the or we draw a line toward the, then it's touched to the single point, this standard graph, then we got the concentration of test solutions. So this is the quantitative method. So this actually qualitative and quantitative methods are exactly similar, but in qualitative method we not using the non-concentration of standard antigens or standard cold antigens, but in the case of quantitative method we using different concentrations of cold antigens. So finally we got a standard graph, and based on the standard graph we finally concluding the concentration of antigens present in the samples.